Here, Dr. Borja Bandera. Welcome to a new video of Pesara. Without the molecule I'm talking about today, your arteries would close in an instant. This molecule is not talked about enough, and it is absolutely key for both your health and your performance. Today we're not talking about anything aesthetic. Is nitric oxide NO an important molecule that you're going to understand today? What are you really going to understand? What is the first thing? What biological actions does it have? This molecule? How is it synthesized? And the most interesting and practical thing we left for the end, how do we increase its synthesis? Nitric oxide has a characteristic, it's a tiny molecule, very small, and it's a gas, it's a gaseous molecule. As a gas, it is very reactive, very volatile, and has a very short half-life. 0.1 seconds, it's over in an instant. It has to be constantly produced because it disappears very quickly like a good gas and metabolizes into nitrites and nitrates, which are then eliminated by your kidneys. As a curiosity, can an excess of nitric oxide react with other molecules like the superoxide radical, which is this one we have here, and generate reactive nitrogen species that are harmful? So we also don't want an excess of nitric oxide, but we also don't want to have a nitric oxide deficiency. Having a small amount of nitric oxide, which in fact this is quite frequent. Nitric oxide is synthesized in the body through two pathways, a classic pathway and an alternative pathway. The classic pathway, which produces the largest amount of nitric oxide, approximately 90%, it is made up of what are called nitric oxide syntheses. The nitric oxide syntheses are nitric oxide syntheses from their English acronym. And we have three fundamentally. The first is the nitric oxide synthesis, one which is the neuronal, right? This would be a neuron, it would be the nitric oxide synthase that occurs in the brain, which is expressed in neurons. Then we have a super important one, which is the endothelial nitric oxide synthase, which is the one that is expressed. This would be a blood vessel. In the endothelium of the blood vessel, in the inner lining of that blood vessel is the endothelial nitric oxide synthase, the endothelial nitric oxide synthase. And then we have one that is a biological resource, it's called ILATINANOS, which is the inducible nitric oxide synthase. This means that it is not constantly expressed in tissues, only when needed, for example, in inflammatory processes. If you remember, nitric oxide is the quintessential vasodilator molecule, and in any inflammatory process, you sprain your ankle, you hit your wrist, what happens? First, inflammation, vasodilation. Well, that vasodilation is due in part to this inducible nitric oxide without rate. That is the classic pathway that contributes around 90% of the nitric oxide in your body. The other 10% is generated by the famous alternative pathway that will sound familiar to you because it is the pathway of nitrates and nitrites. Under conditions of low oxygen or low pH, there is a conversion of nitrates into nitrites and nitrites into nitric oxide. This requires bacterial action, and this conversion can also be achieved through supplementation with nitrates or through the intake of nitrates in the diet. In summary, both the classic and alternative pathways ultimately lead to the formation of nitric oxide, a remarkable molecule. Now I'll explain the biological actions on this side of the board. That is, why is nitric oxide so important? Well, nitric oxide is important throughout the body, I'm telling you. But fundamentally, there are three systems where it is even more important, which are the cardiovascular system, the nervous system is crucial, and the muscular system, the skeletal muscle in the cardiovascular system. Nitric oxide, which as I have told you is a gas, has the peculiarity that, precisely because of its gaseous nature, it freely diffuses through the endothelium of the blood vessels. There they activate the endothelium, the so-called guanylate cyclase enzyme. The guanylate cyclase produces cyclic guanosine monophosphate, which is a second messenger that generates vasodilation in the smooth muscle of the vascular endothelium. That is, it manages to open the blood vessel, to expand it, therefore more blood can pass through it. What does this achieve automatically? Well, it reduces peripheral vascular resistance and blood pressure. Why? Due to vasodilation and reduced peripheral vascular resistance, the heart has an easier time pumping, it pumps against less pressure, it has to exert less force for us to understand. There is also what is called a basal arterial tone of nitric oxide. What does this mean? Well, there is a small but constant basal tonic production of nitric oxide in the arteries. And there are people who, due to different problems, diseases, produce less than this basal amount. And therefore, these people are more likely to have high blood pressure, and they would benefit a lot. And many times, well, they are unaware of this issue, to incorporate more nitrates into their diet or to incorporate strategies that I will now discuss to optimize their nitric oxide formation. And on the other hand, to cardiovascular level, we still continue. Don't miss out. It inhibits platelet adhesion and decreases the proliferation of smooth muscle in the arteries. Why is this important? Well, when we decrease platelet aggregation, we reduce the possibility of forming clots that could end up obstructing a vessel. And we also reduce the probability of proliferation of those smooth muscle cells, which are also, when they proliferate above normal, the ones that generate that atheroma plaque, along with the cells of the immune system, cholesterol, low-density lipoprotein, and other particles form the atheroma plaque that ends up obstructing, well, also an artery. Therefore, it has clearly protective effects at the cardiovascular level, which are very interesting and need to be well understood. Also, at the level of the nervous system, it's super interesting. Nitric oxide is an atypical neurotransmitter, and you might ask, atypical, why? Unlike other neurotransmitters, it lacks a specific receptor. It diffuses freely, because again, it's a gas, right? It diffuses freely, and it acts in a paracrine manner, that is, it acts locally, where it is produced, and in the cells surrounding where it is produced. In the nervous system, in your neurons, the nitric oxide is involved in synaptic plasticity processes. It helps generate memory and learning processes, intervening in a specific process called long-term potentiation in the hippocampus. Therefore, having good levels of nitric oxide is also important for learning new things for synaptic plasticity. And it's interesting, for example, in students or in people who are continuously learning. At the level of the peripheral nervous system, nitric oxide helps to relax smooth muscle, for example, of the enteric system of the digestive system. Remember that in the digestive system, the existing musculature is smooth muscle and therefore of involuntary control. Well, this involuntary control is also partly governed by this nitric oxide, and it helps with peristaltic movements to occur in a healthy way, well, as they have to occur and without causing pathology. And be careful, because an excess of nitric oxide in the nervous system would generate what is called, are you used to hearing? Oxidative stress. But there is also nitrosative stress, which is basically the formation of reactive nitrogen species. And that can occur when there is an excess production of nitric oxide in the central nervous system. For sports followers and performance enthusiasts, performance will always be the priority when everything is balanced correctly. What happens in the muscle? We have said that nitric oxide is a predominantly vasodilating molecule, therefore it will increase the blood perfusion in that muscle. More blood, oxygen, and nutrients will reach the muscle, but less discussed. There will also be a greater blood wash in that muscle, meaning more blood will pass through it. And waste products such as carbon dioxide lactate or hydrogen ions, which can compromise performance, will be washed away. So it's another route by which nitric oxide improves performance. There's something super important and super interesting, which is that nitric oxide reduces the oxygen cost of exercise. What does this mean? This means that for the same amount of work we are going to consume less oxygen, there will be a lower oxygen cost. When we have high levels of nitric oxide, it somehow makes us more efficient in terms of energy consumption and oxygen consumption. It also generates adaptations in the muscle cell, mitochondrial adaptations such as greater mitochondrial biogenesis, and improves recovery. That post-exercise vasodilation is going to bring more blood and therefore more building blocks, amino acids, more fuel for the muscle, glucose and fatty acids. And in general, a muscle that is more perfused, a muscle with more blood, is going to recover faster than a more ischemic muscle, a muscle with less blood, with less access to those nutrients. And now for the million-dollar question, how do I increase my nitric oxide levels? That's probably what you're most interested in from the video. How do I increase the amount of nitric oxide? Well, there are 3 ways to increase it, as we saw in a recent video. Citrulline and arginine are 2 supplements, 2 non-essential or semi-essential amino acids that increase the amount of nitric oxide in your body. The problem with arginine was that it had low bioavailability, a metabolism of high first-pass hepatic, and it didn't last long in your body. So giving arginine directly was not very efficient. Although it is still done, it is given. It's a supplement that you can buy and that has some evidence in conditions like erectile dysfunction, for example. But citrulline had a life, let's say, a better, higher bioavailability, and in this way gives citrulline. Also, we said it could help maximize those nitric oxide concentrations in your body. Why? Because citrulline turned into arginine in the kidneys and arginine into nitric oxide. If we gave arginine, it would turn into nitric oxide, and in turn that conversion would generate another citrulline. Therefore, arginine and citrulline were two molecules that were constantly interrelated. There's another way to not produce more nitric oxide, but to better utilize what you have in your body, which is to have a good status. Polyphenol antioxidants like those in cocoa, tea or coffee, or the isothiocyanates in garlic. Allicin, for example, are antioxidants that reduce the metabolism of nitric oxide. Somehow they protect it and make it last longer. It has a slightly higher half-life and is consumed less. This way, we understand each other. And I'm reducing everything a lot, okay? And the third way, which is also one of the most important, is to increase the nitrate content of your diet. And you can do this in two ways, by increasing foods rich in nitrates. The most classic and the most studied and the most popularly known is beetroot. That's why endurance athletes drink large amounts of beetroot juice to increase their nitrate intake. But you also have it in arugula, in cabbage, you have it in lettuce, in any green leaf. In general, there are nitrates. It is true that the amount of nitrates depends a lot, for example, on the soil where that vegetable has been grown. And it is very variable, and it is difficult to obtain a stable amount if you are an athlete only through diet. For this reason, and because it is also tedious, and many times they are foods that either you do not like or they displace other foods, because you would have to take them in large quantities to get an adequate amount of nitrates. That's why supplements appear on the market that directly provide nitrates, like the one we have in Full Gas, which is this one here that I leave you. And that really, well, it greatly facilitates providing an extra and sufficient amount of nitrates to the diet, enough to improve athletic performance in this case, although, as we have seen, it can also improve clinical aspects such as cardiovascular health or erectile dysfunction. Be careful with providing nitrates, and in high doses in people who are already taking them. For example, antihypertensives, since they can lower blood pressure and they can lower it more than is healthy and more than necessary. They can also cause, due to these abrupt drops in blood pressure, headaches, migraines. It's a common side effect of nitrates. So be very careful. We're not talking about just any supplement. It has side effects that need to be managed, that need to be understood above all. So nitric oxide, a small gaseous molecule, very important, that is synthesized by nitric oxide synthase enzymes, and also through the conversion of nitrates into nitrites and into nitric oxide. Be cautious, as mouthwashes, which is an interesting fact, can be harmful. With antibacterials, they can reduce the conversion in the mouth of nitrates into nitrites and nitrites into nitric oxide by the bacteria that carry out this conversion. It's a bacterial conversion. So this is a curiosity, but well, it's also interesting. They have a biological action, particularly in the cardiovascular, nervous and muscular systems. And it can be increased by the intake of citrulline arginine, having a good antioxidant status, or by the extra contribution of nitrates in the diet. So guys, one more video. I hope it has been useful. I hope you have learned something. I hope you are liking the blackboard. We have improved the colors. Now it looks better, and nothing more than, if you like the video, if it has been useful, then share it with family, friends. See you in the next one. A big hug and keep empowering.